My esteemed viewers, in this tutorial, we once again bring out an algorithm, sorting algorithm, which is based on space-time trade-off strategy in general and space trade-off strategy in particular. You may recall that the previous tutorial happened to be sorting by counting, and this algorithm is called as distribution counting sort algorithm. And this algorithm peculiarly works under linear complexity, and this is the only one algorithm we ever found which will work on linear complexity. And however, this algorithm is to be used only in specialized cases of an array. The specialized case being the array consisting of elements drawn from a very low range. So in a big array, if the elements are drawn from a lower range, then naturally there will be repetition of elements. Elements will frequent. There will be multiple occurrences of same element, because all the elements put together will have come from a small range. And this idea of sorting by counting will not work productively as far as this kind of arrays are concerned, because there will be many number of elements, okay, with the same value. Therefore, since different elements from a smaller range, therefore small number of elements with small number of values, many number of elements will repeat often and often, repetitively. Therefore, it is essential that we should find the frequency of the repetition. Once we find frequency of repetition, we can also find cumulative frequency. This cumulative frequency is also called as distribution of each and every element within the array. That is the cumulative frequency. This enhanced information about each and every element with a special reference to their cumulative frequency will be effectively used in order to place the element in the sorted array. Of course, we will take a simple example to reinforce our understanding on distribution counting sort method, which is based on space trade-off. Let us consider an array consisting of 6 elements, with the highest value being 23, lowest value being 21. Therefore, the range happens to be 23 minus 21, just 2. Therefore, there are repetitions. 23 repeats twice, 21 repeats once, and 22 repeats thrice. So it is very simple to calculate the frequency of each and every element. We will make a table. Okay, therefore the range is 21, 22 and 23. They will come from a small range of 2, that is 23, 21 to 23. Therefore, we will generate the frequency value for 21, 22 and 23. Here it is. Elemental values are 21, 22 and 23. The frequencies are 21 repeats once, 22 repeats thrice, and 23 repeats twice. Therefore, the distribution values or cumulative frequency values are, for this it is 1, it doesn't change, and the second one is 3 plus 1, it becomes 4, and the third one, that is 23, will have its cumulative frequency being 6, which is 4 plus 2, or 3 plus 1 plus 2, that is 4 plus 2, that is 6. Now, wherever 23 occurs, in the first instance of occurrence, it should be placed in the sorted array at a location 6 minus 1. So when 23 occurs over here, its location is 6 minus 1. That is the 5th position. This should be plucked from the original array and it should be placed in the sorted array, the position being 6 minus 1, that is 5. And you should go up to 4, because from 4 onwards 22 will start. Then once again 23 will be repeated over here. This will find the 5th place in the array and this will find the 4th place in the array. Now wherever 22 occurs, so 22 is occurring over here, okay, at this place, okay, this 22 should be taken and placed in the third position, that is 4 minus 1. This minus 1 is done because the array starts from 0, and for this 22 it is 2, because 4 minus 1, this is the third place, this will occupy the third place in the sorted array, this will occupy second place in the sorted array, this will occupy the first place in the sorted array. Then 21, as far as 21 is concerned, its position is 1 minus 1, that is 0. This is how the things are done. Okay, so first I repeat, the elemental values are noted in the table, and how many columns will be there? As many elements which they come in that particular range. Here the range is 23 minus 21, that is only 2, therefore 0, 1, 2. The size of the array is 3. Size of the array is 3, where in this array the elemental values are written and frequencies are written in some other array, and in another array distribution values are calculated, and this distribution values are used in order to place the element, okay, in the sorted array. Of course, while placing, we will enter the sorted array, the empty array in the array, original array, in the backward direction, and we will pluck 22 for example, and we will place it in 4 minus 1, that is third place, and we will just pluck this 22 and it is 3 minus 1, second place, and 23 comes over here. 23 will be placed in the fifth position, that is 6 minus 1, and this 22 is placed in the second, okay, two places are already over as far as these two 22s are concerned. This will be placed in first position, and 21 is placed in 1 minus 1, that is 0th position, and this 23 is placed in 5, 4 and the third position, fourth position. So 23 occurs over here, this will reach fifth position, 6 minus 1, and this will reach the fourth position in the sorted array. Okay, the very important points being, find the frequency, find the cumulative frequency, enter the original array from the backward direction, pick up each and every element, look at the cumulative frequency, lessen it by 1, and place whatever the positional value you will get out of this cumulative frequency, the element that you have plucked from the back end, and place it in the sorted array. This is the simple method. Anyway, now two elements 23 are placed in the sorted array from 6 minus 1, that is fifth position, and in the fourth position. Three elements with value 22 are placed starting from 4 minus 1, that is third position, second position and first position, because there are three 22s, and the lone element 21 will be placed in the sorted array, that is 1 minus 1, that is 0th place in the sorted array. So for example, if this is the array, so this 22 is placed, this 22 is placed, 22 is placed in 4 minus 1, that is 3. And this 22 is placed 3 minus 1, that is 2. This 23 is placed in 6 minus 1, that is 5th. And remember, we are entering this original array in the backward direction from the rear end. And this 22 is placed in 2 minus 1, that is first position. And this 21 is placed in the 1 minus 1, that is 1 was the cumulative frequency, 1 minus 1 is 0, and it is placed over here. And 23, the remaining last 23 is placed over here. So now sorted array appears. You may notice this 23 occurred lately, and it is finding its place over here. The original position of this 23 was 0, 1, 2, 3, 3. After sorting, it finds the fifth position, and that is J dash is 5, J was 4, J was 3, and as far as this 23 is concerned, the ith position was 0 and I dash position was 4. Therefore, I dash is greater than I, and j dash is greater than j. Therefore this cumulative frequency, the sorting procedure by cumulative frequency or distribution sorting is stable, but it is not in place because we exclusively use extra space, because the methodology itself is space trade-off. Now we will try to write the algorithm. Okay, once again this table is held over here for the sake of clarity. Now first of all we have to generate the frequency array. The frequency array will not have anything before, therefore it should be initialized with 0. So for I equal to 0 to u minus L, u is here 23 minus L is 21, 23 minus 21 is 2, therefore this will run for 3 places, 0, 1 and 2. Okay, so distribution value, that is frequency value, is 0, it's initialized to 0. Now this will help to calculate the frequencies. Okay, the frequency is to be calculated for every element, therefore for I equal to 0 to n minus 1, okay, the first element is 23, okay, the distribution value, that is frequency value, a of I is 23, 23 minus L, this is the lower limit, it is 21, 23 minus 21 is 2, therefore d of 2 will be equal to d of 2, earlier it was 0 because we have initialized over here, d of 2 plus 1, 0 plus 1, 1. Okay, this place will get 1 now, and once again 21 is appearing, it is 21 minus 21, 21 minus 21, 0, d of 0, 0th position is equal to what was there in the 0th position, it was 0 plus 1, so it will get 1. Once again for 22, it is 22 minus 21, it is 1, d of 1 equal to d of 1 plus 1, okay, it was 0 before, so it will get 1. So this will get another 1. So again as 23 there will be 2. Again as 22 here it will be 2 and here it will become 3. So frequency array is generated. Now we will compute the cumulative frequencies. Generating cumulative frequencies, we have to make use of this frequency array. Okay, 1 is here and we need not have to touch this. Okay, this is to be increased by adding this and this, and this is to be increased by adding this and this, and this, 4 and 2, it will become 6. Therefore this for loop will run from 1 to u minus L, that is 1 to 2 in this particular case. Okay, d of j, d of 1, that is this one, d of 1 equal to d of j minus 1, that is 3 plus d of j. Okay, plus d of j is 0, d of j is 1, okay, d of j minus 1 is 1, so 1 plus 3, it will get us 4. And once again it is starting from 1, therefore the other round is available is 2, it is over here, it is dj minus 1, that is 4, okay, that is 4 plus back the d of j is 4 and d of j minus 1 is 2, therefore what we get is 6. So this will help to calculate the distribution values. Okay, distribution values is gotten by this particular for loop. Okay, anyway, for creating distribution values we have made use of the frequency table. Okay, and now with the availability of distribution table we will just place the elements in the respective positions. Okay, so for I equal to 0, this is the algorithm. For I equal to 0 to u minus L, this is initialization to 0 of all the 3 elements. Okay, so in general case whatever the number of elements that appears between 0 to upper limit minus lower limit. Okay, compute the frequencies. We can compute the frequencies by just taking each and every element and just counting as to how many times it repeats. Okay, frequency array is generated, then making use of frequency array we generate distribution array. Okay, therefore distribution array starts from 1 to u minus L upper limit minus lower limit. It starts from 1 because the first elemental frequency cannot be, that itself is the cumulative frequency. Okay, therefore cumulative frequency is calculated over here. Now it is only making use of this distribution array and placing the elements by entering the array in the backward direction. Okay, it's here, so we will enter 22, we will look at 22, we'll look at this for loop. it starts from, for I equal to n minus 1, that is n minus 1 down to 0. So it is n minus 1, this is n minus 1 down to 0. And we will make use of the values available in the distribution table, cumulative frequency table. So J is equal to A of I minus L. A of I is 22, 22 minus L is 22 minus 21, that is 1. Okay, J equal to 1. So yes, D of 1, what is available to us is, D of 1, what is available to us is 4. So 4 minus 1. What to do 4 minus 1? For the simple reason that the counting starts from 0. Okay, 4 minus 1, 3. So S of 3 will contain A of I. A of I is 22. So the third position in the sorting array, we insert 22. Similarly, and D of J will be lessened by 1 because it's one value is already taken. Okay, as we take one value, so let us say it becomes 6 minus 1. When once again 23 occurs, it should be lessened by 1 because fifth location is already occupied. Now we have to place the next available 23 in the fourth place. Therefore, that will also go lessening. Right. So distribution value is to be lessened by 1. Okay. So till all the elements are completed, we make use of this distribution array. Okay, it will start from n minus 1. This is a very important step. It will start from n minus 1. It will go down to 0. Then it will calculate the position of the element. Position of the element, or the value that is to be taken from the distribution value. The position from where distribution value is to be taken. And this distribution value is used in order to place the element that is plucked from the original array into the sorted array. Now we will take yet another example. Okay, assuming the set of possible list of values is A, B, C, D, sort the following list in alphabetical order by the distribution counting algorithm. A, C, D, C, B, A, B. Okay, the range is once again D to A. So array values are just A, B, C, D. A repeats twice, B repeats thrice, C repeats twice, and D repeats 1. And cumulative frequency, when you calculate cumulative frequency, 2 is to be retained. It is 3 plus 2, 5. Okay, and 2 plus 5 equal to 7, and 1 plus 7 equal to 8. Now we will enter the array in backward direction. Okay, the original array is B, C, D, C, B, A, B. B, C, D, C, B, A, B. So we are going to enter in this way. So it is B. So as far as B is concerned, we have the cumulative frequency to be 5. So we should lessen it by 1 because the array numbering starts from 0. So this B is to be placed in the fourth position. This is 0, this is 1, 2, 3, 4, 5, 6, 7. So this should be placed in, B is to be placed in 5 minus 1, that is fourth position. So here it is B. Then A appears over here, and A has a cumulative frequency of 2, therefore it should be placed in 1, 2 minus 1. So here comes A. Once again there is A. So A is to be placed over here. So this A remains and this B is there. Okay, then comes B, another B. So B is already placed in fourth position, and this B is to be placed in the third position. Okay, it should be written over here. B is to be placed in this position. A is there, and B is there, which was done in the earlier iteration. And then comes C. C is to be placed. This is the first C that is occurring. C has a cumulative frequency of 7, therefore it should be placed in the 6th place. C is to be placed in 6th place. C is to be placed in the 6th place. Then comes D. D has a cumulative frequency of 8, therefore it should be placed here. Then comes another C, C is to be placed over here. Okay, then comes another B, B is to be placed over here. So now sorted array being A, B, B, another B, C, C, D. You might have noticed the relative positions of equal valued element remain the same even after sorting. Therefore, cumulative frequency based sorting algorithm is stable, but it is not in place because we have hugely used many arrays, therefore huge amount of space. Is the distribution sorting stable? Yes, it is stable. Design an algorithm for sorting any array of size n whose values are n distinct integers from 1 to n. There is an array A which has elements from 1 to n. Let us say 1 to 4. 1, 2, 3, 4. Now we have to generate a sorted array. Okay, by writing one statement. Okay, now what we can do is, yes, sorted array of EFI. Okay, for loop starts from 0, of course. For I equal to 0 to n minus 1 do. Okay, sorted array of EFI minus 1. EFI is A of 0. A of 0 is 1. 1 minus 1 is 0. Therefore, S of 0 equal to AFI. Once again, S of 0 equal to AFI. AFI is A of 0. A of 0 is 1. Here we are generating the position numbers starting from 0. Here exactly whatever that is available over here is inserted. Because 1, 2, 3, 4 are different, they do not come with a cumulative frequency. Okay, they have the cumulative frequency equal to 1, it is not repeated. Anyway, this is the way to sort an array of n elements whose values are n distinct integers from 1 to n. There is no repetition. So with this we complete the tutorial 2, which majorly consisted of distribution counting sort and distribution counting sort. Again, I will just recall your memory. Please be informed that this algorithm is a linear algorithm because it just makes 2 consecutive passes through input array. Once here, and once here. Actually, it's here and it's here while creating frequency table and distribution table. And here we pluck each and the value in the distribution table, and it is only a replacement or the position shift of an element drawn from the unsorted array to the sorted array. So unsorted array is different and sorted array is different. Okay, so we derive the positions of these elements in the sorted array by looking into distribution array. Distribution array contains simply the cumulative frequency of each and every element. So with this we will complete this tutorial.